Three-phase induction motor. Objectives are conduct the no load test and block rotor test on an induction motor. Able to draw performance curves of induction motor. Testing of induction motors. To know performance of induction motors, the following tests are conducted. First one is the no load test, and second one is the blocked rotor test, and next one is stator resistance test. In no load test of an induction motor, it is find out the no load losses, no load power factor, no load resistance or not, and no load reactance X naught. This test is same as the no load test on a transformer. The no load losses are the core loss and a small amount of copper loss in stator winding. The rotor copper loss, it is negligible due to low rotor current at no load and friction and windage losses. Circuit for no load test. The connection diagram of no load test is three-phase supply, R phase, Y phase, B phase, and here the voltmeter across the three. If here the line volt, that is voltmeter across the lines, that shows the line voltage, and armature ammeter is in series connected, that is a load current it shows, and wattmeter W1 consisting of current coil, that is series in with load, and pressure coil or potential coil is parallel with the two terminals. Here W1 is connected to R phase and Y phase, and W2 is connected to B phase and Y phase. Here the Y phase is common for these two wattmeters. So equivalent circuit is for no load, that is V1 and I1. So here equivalent circuit is showing this one. Is the equivalent circuit. I naught, IW, I mu, R naught, X naught. So the motor is rotating. The no load test procedure, when a three-phase supply is fed to the stator winding and rotor rotates freely without mechanical load on its shaft. The power input to W naught to the motor is measured by two wattmeters W1 W2. Sum of W1 and W2 gives the total reading of power. The no load input power W0 is equal to the mechanical losses and core losses of the motor. Here, to more accurate, the stator copper loss is neglected since no load current is very less. Let input power is W0, V1 be the applied voltage and I1 be the no load current. It is considered for phase values. Here, therefore, cos pi naught is equal to W naught by V1 I naught and W naught is equal to V1 I naught cos pi naught, and also R naught is equal to V1 by IW, that is equal to V1 by I naught cos pi naught, and similarly X naught is equal to V1 by I mu, that is equal to V1 by I naught sin pi naught. Here IW is the working component of no load current I naught. Mu is magnetizing component of no load current I naught. The no load losses for different voltages can be plotted as shown in diagram. These curves are obtained from the data on no load test. This is the here the no load test for different voltages no load losses are plotted. Here input voltage is varying along with the x-axis. It is taken as along with x-axis, and input current and input power, that is along with the y-axis. So if the voltage varies, current is varying slowly towards the higher values. In the similar way, the input power also varying. So this is the diagram. So this is the graph. See here, input current, input power, input voltage. Blacked rotor test of an induction motor. This blacked rotor test is also known as short circuit test. This is similar to SC test on a transformer. This test is used to find out the total resistance of the motor R01 and the total leakage reactance of the motor X01. Here power factor on short circuit blacked rotor test. So here the connection of diagram for blacked rotor test on 3-phase induction motor. Here this is the stator and this one is rotor. It is blacked, that means it is not rotating. It is not rotating, it is blacked. When supply is given to the motor, it is not rotating, it is blacked. So that is called black rotor test. So now here for three-phase supply is connected to the auto transformer, and this is the voltmeter. It measures the voltage between these lines, and ammeter is measures this current, load current. This wattmeter are connected. So here this is the current coil, this is the pressure coil. So it is connected between the, so this phase and this phase, this phase and this phase. So now here wattmeter 2 is connected. So this third phase and this second phase. So this is the common terminal for this wattmeter, and this one are connected as a common terminal phase. Now the black rotor test is locked by means of a brake. That means it is not rotating, it is braking. So brake means there is no rotation, therefore it is called black rotor test. Then rotor windings are short circuited at slip rings if it is wound rotor type. So now apply reduced voltage to stator terminals up to 10 to 20% of normal voltage. Don't apply the more than that voltage. When we are applying more than that voltage, the stator is producing huge amount of current, then it is immediately burned out. So it is very important. 10 to 20% of normal voltage will apply. It may be adjusted that the full load current flows in the stator and the rotor is blocked. S is equal to 1 or slip is 1. Now the equivalent circuit of motor is exactly like a transformer in short circuit secondary. So the equivalent circuit as follows: VSC and ISC are for phase values of an applied voltage and current. WSC be the total power input, that is root 3 VSC ISC cos pi s. Cos pi s is equal to Ws by root 3 Vs ISC. Here VSC ISC R naught X naught, this combination is Z naught 1. Combination is Z naught 1. Here the total resistance referred to, so here R naught 1 is equal to Z naught 1 cos pi s. Here Z naught 1 is, so VSC by ISC. That is here the R1 plus R2 dash, that total reactance as referred to stator side. Now X naught 1 is equal to Z naught 1 sin pi SC. Here that is equal to VSC ISC into sin pi SC. Now X2 naught 1 plus, here this is into sin pi SC. Here this is the sin pi S, and here cos pi S. Here this is the cos pi S into, here they written here, so this is right here in this way. So now next, from this test we can plot a wave from between input voltage and current. Now here this is the input voltage and input current, input power, and it shows the here this is the current, voltage, and this is the current, and this one is power. The stator resistance test, it is necessary to determine the value of R2 dash and hence R2 to find out of the shape of this speed torque curves slip for pull out conditions. So for this purpose the stator resistance R1 can be measured by using DC current through stator winding. The ratio of DC voltage across the phases to the DC current gives the resistance R1. Here, therefore, rotor resistance as referred to stator R2 dash, that is equal to R01 minus R1. There is no easiest method to separate the two reactants X1 and X2. In most of motors, X1 and X2 dashes are assumed as equal values. In this, we have discussed no load test, blocked rotor test, equivalent circuit, performance curves from blocked rotor test.